Hello physical science student, welcome to the final video in motion. In this one we're going to look at velocity time examples. In fact we're only going to do one example, but it's quite a complicated one and it contains pretty much everything that you need to know about interpreting velocity time graphs. And so we'll put our theory into practice. So, looking at this is a complicated description. It's describing an elevator. And the elevator is going up and then coming back down. And so you could be asked, describe the motion that's given in this graph. And you'd be asked a whole lot of other things like what's the velocity at certain times, what's the displacement, what's the acceleration. You might be asked to sketch the acceleration time graph, and if this example was the case, they might end up asking you where does the elevator end up. Does it, if it leaves from the ground floor and goes up to the second story, this is the going up and this would be the coming back. And does it actually come back to the ground floor or does it go somewhere else? Now how would we do that? So before we describe it, if we were asked to put it into words, we'd have to make some calculations and work some things out. So first of all, working out the displacement. Now what we'll do is we'll divide this into chunks as we've done previously. And if I get my pen up here, so this triangle here is, what is it, 5 by 8, which is 40, so that's going to be 20 meters because it's meters per second and this is seconds. This is now, and so we'd work our way through this, working out these areas, recognizing that these guys here give us positive displacement. And let's pick another color. And let's make this a bit thicker. These, you can already guess what I'm probably going to say. These are going to be our negative displacement. Now we could be asked, what is the distance travelled? In which case we forget about this being negative and we just add up all the areas between the motion graph and the zero axis. And so we'd add all those together. Okay? Hopefully we're pretty good at doing that now. What else could we be asked? Well, there they are there. Luckily I've calculated them for us. And so this would be, actually let's work this out whilst we're here. So our positive displacement is going to be 20 plus 100 plus 10, which is 130 meters. Our negative displacement, which is going to be, what's that, 120, 135. Okay, so that means, now if we put a negative there and we add them together, so 130 plus minus 135, we get 5 meters. So it actually, if that's the ground floor, it goes up and then it comes back down and it ends up at the lower ground. I think that's what they call it, or the basement. And that's what's actually happening in this case here. And we wouldn't know that if we hadn't worked out the displacement on this velocity time graph. Right, we can get rid of that now. What about working out the velocities? Do we remember how to work out the velocities on a velocity time graph? You just read it off the graph. That was a trick question, but you'd be amazed how many students can't work out how to get the velocity off of a velocity time graph. So what's the velocity at 10 seconds? Just read it off the graph. Now what about working out the accelerations? Read it off the graph? No. Do you remember? It's the slopes. And so to work out the acceleration for this motion, anywhere where there's a slope, there's an acceleration. And remember, if you're climbing up the hill, that's a positive slope. If you're going down the hill, that's a negative slope. So what's this one? That's a negative slope. What about this one? That's a positive slope. and magically it appears. So here's our run, there's our rise is 8, so our acceleration is 1.6 meters per second to the minus 2. And if I press that again, and so you'd work through these, and we've done our calculations here, just remembering, of course, let's just pick a different color. If we, let's go blue actually, for this negative here or this negative here, what we're doing is we're going from there to here, and we're not doing rise over run, we're doing fall over run. So that's our fall, okay? And so that would be our minus 8. And the same here, we're going from here to here, but following the axes. So there's our run, and there's our fall. And that's why it's a negative slope. Right. Let's do that now. So we've worked out our values, recognizing, of course, that this area here and this area here have 0 acceleration. What would our acceleration time graph look like? Well, we'd be able to sketch it, but I've got one to appear shortly, I think. Oh, there we go, I did that. Okay, and this is what our acceleration time graph looks like. So there's our 1.6, then it goes for 0 for a period of time, and then it goes down to minus 3.2 for a short period of time, then it goes back to 0, then it goes down all the way down here to minus 4.8, and then back to 0, and then up to positive. And that's what you'd be expected to do in an exam. Alright, hopefully you follow all that and that made sense to you. So from this graph, you could then write more than a paragraph or two detailing where this object is at any instant on this graph. You could describe its displacement. If I wanted to know, for example, if I wanted you to describe the motion or the object at that point there, you would know its velocity, you would know its acceleration, and you could, by working it out, know its displacement. But if you were to describe the whole motion, you could tell the whole story. And basically it is a bit of storytelling. But you need to do some calculations to get the full story. Right, I think that's just about it. There's probably one little thing here. We will be doing some questions where you need to be able to convert kilometers per hour to meters per second, and the simplest way is to remember this, where if you're going from kilometers an hour to meters per second, you divide by 3.6, and if you're going the other way from meters per second to kilometers per hour, you times by 3.6. But it's a valuable thing to actually know why that is the case, and so let's do it. If, for example, if we have something as meters per second, remembering that the velocity formula is v equals s on t. So if we have it in meters per second to the minus 1, what we're effectively saying is we've got meters, because we've got our displacement in meters, and we've got our time in seconds. Now if we're saying that we want our velocity, using this formula, to be kilometers per hour, we would have our displacement in kilometers and our time in hours. Now how do you convert one to the other? Quite simply, all you have to do is, if you have meters per second, to convert it to kilometers per hour, you convert what you have in meters into kilometers. So if we had 100 meters, for example, and let's say 20 seconds there, whatever value that would give us, what would that give us? 5 meters per second. Yeah, that was lucky. Now, to convert that into kilometers per hour, we could use this technique here if you remember it, but you may not remember it, and so it's a good idea to work it out. And so what we do is we convert 100 meters into kilometers. What's that? That would be 0.1. And 20 seconds into an hour. That gets a little bit harder, but basically what you've got to recognize is you've got 20 seconds, and then that would be divided by how many seconds there are in a minute, which is 60, and how many minutes there are in an hour, which is that. Okay, and that gives us that conversion. And that should give us whatever it is in kilometres per hour, and vice versa. Most commonly, we would go the other way, kilometres per hour into metres per second. So let's do an example here. Let's rub some things out. Oh, that was pretty cool. Is it going to let me do it? Sort of. Alright, let's put some numbers in here and just convert it. Right. And let's change our colour. So if we were doing 5 kilometres an hour, so that would be 5 kilometres in 1 hour. What we do is we convert it into our units that we're going to use over here. So 5 kilometres is of course 5,000 metres, and 1 hour is 1 hour times by how many minutes are in an hour? 60 times by how many seconds in a minute. Alright, and we do that calculation, making sure that we put this in brackets because sometimes our calculator wouldn't do it correctly, and we get our answer in meters per second. That's how you do it. Alrighty, you'll get a bit of practice at doing that. And I think that's the end. Yeah, because you'll be doing some more questions in class. Goody, lucky you. So, cheerio.